Dear friends, welcome to my channel. In this video I am telling you about bridge versus switch network. A network is formed when two or more devices connect to share data or resources. Let us discuss the difference between bridge and switch network. A bridge connects smaller network segments to form a large network, and it also relays frame from one LAN to another LAN. On the other hand, the switch connects more network segments as compared to the bridges. This is a basic difference between bridge and switch. Dear friends, please watch my video till the end and subscribe my channel, and don't forget to comment on my videos. Bridge versus switch network. A network is formed when two or more devices connect to share data or resources. A large network may need to be subdivided for efficient frame delivery or the traffic management. Bridges or switches are used to connect these subdivided segments of networks. In a long way, the terms bridge and switch are used interchangeably. Bridge and switch both provide the same functionality, but the switch does it with greater efficiency. A bridge connects smaller network segments to form a large network, and it also relays frame from one LAN to another LAN. On the other hand, the switch connects more network segments as compared to the bridges. This is a basic difference between bridge and switch. Definition of bridge. Bridge is a networking device used to connect the network segments of a large network. Bridge operates at two-level, example, physical layer and data link layer. Being a physical layer device, it regenerates the signal it receives. Here, it acts as a repeater. The bridge, being a data link layer device, identifies the source and destination address of the frame it receives. It relays the frames between two separated LANs. On the other hand, the bridge also has the logic of filtering the traffic, separating the traffic of each network segment. Bridges filtering capability. Bridges filtering capability can be explained with an example. You can observe the figure above. A bridge has joined to network segments. Now when station A sends a packet to station F, the packet arrives at the bridge. The bridge identifies that the intended recipient F is in the lower segment of the network. So, the bridge allows the packet to cross into the lower segment, where the packet is received by the station F. When the station A sends a packet to station C, the packet arrives at the bridge. As the station A and C are in the same segment, the bridge blocks the packet from crossing into the lower segment and relays the frame to station C. Types of bridges. We will discuss types of bridges. Simple bridge is the most primitive bridge which links to network segments. It has a single table which contains the address of each station included in both the segment. Multiport bridge. It links more than two network segments. It has the number of tables equal to the number of network segments it connects. Each table contains the addresses of all the station reachable from the corresponding port. Transparent bridge is a bridge whose existence is not known to the stations. If a transparent bridge is added or removed from the system, the stations are not required to be reconfigured again. Definition of switch. Whenever we talk about the switches, we must specify the level at which the switch operates. We have two types of switches: a two-layer switch, three-layer switch. The two-layer switch operates on two layers. Example: physical and data link layer. A two-layer switch has similar functionality as that of a bridge, but has faster forwarding capability and greater efficiency. On the other hand, a three-layer switch acts as a router, which receives, processes and forwards the packet. Two-layer switch. In this video, we are discussing two-layer switch, which is similar to the multiport bridges. It can connect multiple network segments. A switch has a buffer for each link connected to it. Here, the receiving link buffers store the packet and check for the outgoing link. If the outgoing link is free, switch sends the packet onto the outgoing link. Switches are fabricated on two strategies that are store and forward and cut through. The store and forward switch stores the frame in the receiving link's buffer until the entire packet arrives. On the other hand, the cut-through switch forwards the packet as soon as the destination address of the frame is identified. Every switch has a control unit and a switch table. The control unit processes the frame to find the destination address of the frame and consults the switch table to find on which link the intended receiver is connected. Conclusion. Bridges were introduced when the classic Ethernet was used. Hence, they tend to join fewer networks. Switches are the modern bridges, and they tend to join comparatively more networks together and are more efficient than bridges. Dear friends, thank you for watching my video. Please subscribe my channel and don't forget to comment on my video. I will keep making these types of useful videos in future. So stay connected and make sure to subscribe. My channel is growing continuously due to your support. Thank you.